The star field does not stay still long enough to measure. One point near the galactic center shifts position while you are still tracking it. Another drifts sideways across the background before the navigation grid finishes updating. Orbital markers begin correcting themselves mid-calculation. That should take years. Instead, entire stellar paths are visibly moving inside a single observation window. Sagittarius A star compresses millions of suns into one gravitational center. The closer objects accelerate so violently that stable reference points begin disappearing faster than the systems can rebuild them. The sky keeps updating faster than the math stabilizes. The sky is moving wrong. Not slowly, not like normal orbital motion. One star near the center of the Milky Way shifts position while you are still watching it. Another cuts a faint arc through the darkness beside it. The entire star field seems to rotate unevenly around something you cannot fully see. Sagittarius A star sits inside a region holding roughly 4 million suns, crushed into one gravitational center. NASA observatories tracked stars here reaching more than 15 million miles per hour, around something massive enough to distort orientation itself. Your balance goes first. Forward stops feeling reliable because gravity is no longer pulling from one direction. Every movement changes direction halfway through the motion. You lock onto one point in the sky, but the horizon slides sideways before your body adjusts. Even standing still begins to feel like falling. Then the stars speed up. Thin trails of light begin wrapping completely around the black center. Distance stops behaving correctly. Objects closer to the core appear to slide faster than objects beside them. Navigation systems lose their reference points almost immediately. Deeper in, entire orbits start folding inward. Orbit lines keep crossing over each other. One glowing stream of gas bends sharply around the galactic center, then twists again as another stellar path cuts directly through it. The motion keeps breaking its own patterns. Some of the paths start folding back toward the center. Near Sagittarius A star, entire orbital paths begin drifting out of place. European Southern Observatory measurements captured entire stars whipping around the center fast enough to redraw their position within a human lifetime. Even objects far from the core start getting pulled off stable paths. A route that looked stable seconds ago begins curving inward. The shift hits your body before the readings change. One side of your frame strains harder than the other. Metal joints groan unevenly. A straight acceleration drifts sideways hard enough to send the entire frame into rotation. Ahead, a ribbon of glowing gas folds almost in half around empty space. Instead, trajectories keep mutating as nearby stars drag against each other through overlapping fields. Escape calculations collapse almost immediately as nearby objects begin shifting in different directions. Even the dark areas are shifting now. One bright star finally holds a clean path. It curves smoothly around the darkness instead of twisting apart like the others. The loop stays consistent long enough for your navigation markers to stabilize. For the first time since entering the region, the motion almost looks understandable. For the first time, the motion follows one consistent rule. Astronomers tracked a star called S2 completing an orbit around Sagittarius A star in roughly 16 years. Hubble and European Southern Observatory measurements watched it dive toward the center, then return along the same curve. The motion repeats, just enormous mass bending every orbit around it. Your body finally stops fighting every movement. The sideways pulling eases for a moment. Rotational drift slows. Directional systems finally hold the same calculations for more than a few seconds. A controlled burn finally sends you where it was supposed to. Ahead, several orbital loops overlap in smooth, glowing layers around the central darkness. For a moment, the structure behind the motion becomes visible. Millions of suns compressed into one region, pulling everything nearby into violent acceleration. The stars closest to the center whip around fastest, tracing tight, repeating curves through the dark. For a few seconds, escape routes start looking possible again.
The reply signal comes back late.
A short transmission pulse leaves the system, crosses the dark center, then returns stretched and uneven, like part of the message took a different path through the region. Another pulse arrives before the first one finishes. Audio begins overlapping out of sequence inside your headset. Now even the light starts arriving wrong. The smooth orbital loops ahead begin stretching across the background stars. Light from opposite sides of the galactic center no longer arrives in straight lines. Some stars appear doubled. Others drag sideways across the dark like wet paint pulled by gravity. Your maps stop matching the sky. A correction sent 3 seconds ago arrives too late to match the current position. Distance readings shift while you are already moving through them. The delay compounds until navigation begins steering toward empty space. Astronomers observing Sagittarius A star measured relativistic time effects around the region as stars accelerated near the center. The deeper objects moved through stronger distortion, and their light reached observers warped by gravity. Now the terrain itself feels unstable. Not physically moving like an earthquake, worse. Straight paths stop staying straight. Background stars slide across positions they should still occupy. A dark section ahead briefly bends the entire star field around it, warping the sky into a stretched ring before the shape collapses again. You stop trusting the empty space between objects. Beyond the warped signals, the entire galactic center keeps moving in layers. Thousands of stellar trails circle the darkness at different speeds, crossing over each other in enormous curved bands that never fully repeat. Some loops tighten inward, others stretch wide before disappearing behind drifting clouds of distorted light. The motion almost looks organized from a distance, until the patterns shift again. Understanding the pattern does not slow it down. Sagittarius A star sits inside one of the most extreme gravitational environments ever observed. Millions of stars crowd the region around it, all pulling against each other through overlapping distortion. Even after the rules become visible, the terrain changes faster than navigation can adapt. The failures stop arriving one at a time. Navigation drifts. Signal timing breaks apart again. Structural stress climbs unevenly across the frame as nearby gravity gradients shift direction mid-course. A route calculated seconds earlier bends into a different orbit before the correction finishes. Ahead, the darkness disappears behind layers of curved starlight. For a moment, the entire region looks fluid, as if the sky itself is circulating around the center. Background stars smear into long, glowing arcs, while faster objects carve bright loops through them. No safe distance appears. No stable horizon returns. The system stays unstable even after you finally understand it. The transformation never stops.